And I am now honored to introduce our next speakers. And they are Marc Schipper and Manouchehr Shamsrizi. And sorry, Manu, I never really pronounced your last name, so I hope I did it right. Marc Schipper is a professor of psychology and neuroscience at the University of Applied Sciences and Arts in Ottersberg, which is close to Bremen. And also, he has an affiliation with the Apollo University for Health Economy in Bremen, Germany. And his interest and scientific work is focused on the intersection of neuroscience and AI. We are very excited to listen to his perspectives on subjective reality, constructivist mechanisms, and digital encounters. So this talk is like a twofold talk. So the second speaker, Manouchehr Shamsrizi, short introduction to him. He is among the most publicly prominent voices of Germany's younger generation, quoted from the Washington Post. And everywhere where the improvement of political conditions still has considerable scope. That is from Republika Festival. He is a co-founder of Humboldt University at Berlin and also a co-founder of the Game Lab Berlin and a co-founder of the Yunus Center for Social Business and Values at Leuphana University, Lüneburg, which is a collaboration with the Nobel Peace Prize laureate, Professor Mohammed Yunus. Which was initiated by him. And he's also a former Ariane Rothschild Fellow of Innovative Social Entrepreneurship at the University of Cambridge and Global Justice Fellow at Yale University, a Fellow of the German Council on Foreign Relations, and was honored as a Fellow of the Royal Society of Arts, a leader of tomorrow of the University of St. Gallen, and a global shaper of the world economy. And his primarily background is in political philosophy, and he's holding a Master of Public Administration. So let me welcome and give the stage now to Marc Schipper and Manouchehr Shamsrizi. So thank you very much.
Welcome, folks, from Bremen and Hamburg. I will just join my screen with you and show you a picture, and then we will get into the talk, and I will tell you what we will tell you in the next hour. One moment. So there we go. I hope you have all a nice picture of SAAI in the background, and you can hear my words. And just a short introduction. Christoph already introduced us in a fine way. I'm Marc, and together with my partner Manu, I will tell you something about subjective reality, constructivistic mechanisms, and digital encounters. So what does that mean? We want to give you a short introduction into subjectivity and give you some evidence for the reality being subjective. We will have some examples from the arts, and Manu will tell you something about the digital encounters, but maybe Manu wants to say some words.
Okay, hi guys, greetings, and well, Christoph and Marc already said everything. I think it fits perfectly into the amazing SAAI setting as what you're going to hear and experiences between all kinds of disciplines, which is also why it's an honor to be here and be here with Marc. And I'm really looking forward. If it leaves you a bit more confused than you came into this lecture, I think in the disciplines Marc and I are from, confusion is not necessarily a bad thing. So yeah, let's get started.
Yeah. So to our backgrounds, I'm a neuroscientist and a psychologist, a cognitive scientist. Manu is coming from the area of philosophy and is in all areas on the way. And we are both connected by the Institute for Psychology, Arts and Society, which is held in Bremen. And this is our connection. And now we will try to give you some insights into the psychology of subjectivity. So we will try to keep it kind of short, so we have some time for discussions in the end. And if you have any remarks or something, just let me know, and we can put it into the talk. Okay, so what do I want to tell you? Maybe you know this person. This is David Lynch. David Lynch did some movies, for example, Lost Highway, or a series like Twin Peaks. Maybe most of you know this series, and there he plays with reality. So these movies are very subjective, and many things you can't even understand, and you can't understand the behavior of these people, and he really plays with subjective reality like no other person on this planet, in my opinion. So, but even if you see these figures doing strange things, it's not that strange, because I'm working in the field of psychiatry, working with people suffering from schizophrenia and so on. And so this disruptive behavior, the strange behavior, is something which is going on in our minds, and it's reality. And we want to have a scientific look at this kind of subjective reality. So, and therefore, we will start a short journey into the area of cognitive psychology, and I will give you some insights on cognitive psychology, and we will also have a look at some philosophical footnotes. We will not go too deep, but just want to give you an introduction. And so we start with looking at our visual system. So what we are talking about is that reality is not really objective if it's going through our minds. And how can I show you something like this, and how can I give you evidence by using the visual system, for example? So what you see here is our eye, and here we have a stimulus. And the stimulus is a light, a candle in this case. And the stimulus is broken through the lens into our eyes, and it's shown on the retina. But it's a mechanism like in the camera obscura, which we know from René Descartes. It's turnaround. So the picture of this candle is screened in the wrong way on our retina. In our retina, there are our photoreceptors. And then this picture is given into our brain. So when it arrives in our brain, it has to go through our visual roots, and it arrives in our occipital cortex, which is the back end of our brain, which takes about 1/3 of our brains, right? And now let's see what we did here. We did an fMRI scan of our brain during perceiving visual stimuli. And what we see then is first that the candle, for example, is a screened turnaround into our occipital cortex, which we call a retinotopic mapping. So retinotopic because it comes from the picture of a retina, which is projected into the backside of our brain. And when it's projected there, even more happens. So there are different areas here. So what we did here was an fMRI scan, and you know our brain is folded kind of. So if the brain is folded, we cannot really look at different areas. So we want to have it straight. So what we do is a flattening. And so we see the folded brain as one region on the ground. And now what we can do is make a mapping, and we have different areas in our brain. And this area V1 is our primary visual cortex, which is mainly doing just contour integration. So this area in the brain is not looking at colors, it's not looking at forms in general, it's not looking at the movement of the figure. It's just looking at the contours, and other areas are looking at the color and so on, and it's all separated in modules. And one of the biggest problems in neuroscience in general is the binding problems. So how are these several parts binded together again in the end to give us one percept? So, and these pictures nicely show us that our brain is constructing the image of the world. So we see things in the world and they are projected into our back brain, and then it takes the things out of each other and puts them together again. So it's a construction mechanism. It's always constructing this machine we have in our heads. Well, and that's an interesting fact. And it's very interesting and very important, this fact, when I'm teaching young psychiatrists, because they have to know that if a person with a schizophrenia who might have an auditory hallucination, then it's not just a thought, it's really there for this person. And this we can show in fMRI studies again. So if we put a person with auditory hallucinations into an fMRI scanner, what we see is activation in his primary auditory cortex when this person is hearing the voices which are not there. So for this person, these voices are real, they're reality. So for psychiatrists, it's very important to know that reality is subjective. And for people who are interested in AI and arts, it's very important too. So this is why we are talking about this. I want to give you some evidence that, that reality, in fact, is something subjective when it gets through the filters of our minds. So I want to give you some principles how our brain is building informations and is doing things with the perceptions it gets. So what our brain does, and we have many experimental psychological data for that, is it has some principles for structuring information, grouping principles, which we know from Gestalt psychology. Gestalt psychology is looking at these things and ask the question, how do we group things together to make a visual percept out of them? Well, not just a visual and auditory or whatever for all modules. So if you look at this figure A, you see some stripes here. And if I ask you to group these stripes and tell me what do you see, most people will tell me, well, they see 4, well, smaller roots or something. Like this one. So they group these two things together, which is more likely than grouping these two things together. So, and this is what our brain does. It looks at how do things go together and groups them, if it makes sense. And for the brain, it makes sense when things are near together. So this is the law of closeness. If I ask in this one, what would you put together to one percept? Most people would say these 2 gray lines are doing one percept and not this one black line and the gray line. So here we have the law of similarity. It's another law which our brains use to structure information. If we look at this one, we have another one. This is the law of good continuation. So if I ask you, well, where's this one ending? Most of you would more likely say it's ending at the 4 than at the 3, I guess, huh? And so this is why our brain is seeking for continuation. So many people say it's seeking for coherence, right? This is a coherence process. And here there is a famous neuroscientist from Montreal University in Canada, McGill University. And this is Robert Hess, and Robert Hess says what works here is the so-called association field. So this association field looks how the angle is between these different stimuli. And so this one works out very nicely. So we integrate these 2 figures to one percept and not this one to this one usually, if there is not a rule which is telling us to do something else, right? So these are Gestalt laws. Then we have another phenomenon, which is the fill-in syndrome or symptom. So what you see here is a Kanitsa triad or a Kanitsa triangle. So what you see here are different forms, geometrical forms, like the white ones here. But what pops out first when you look at this picture is the triangle in the middle, the black one here. I guess you might see this now. So this is not understandable for our brain, so it tries to give us coherence, so it fills in things which are not there. So if there's something missing, it puts something into it. So this is fill in. And it even works if you have not really this corner thing here, but you have rounds or something. So you have a very nice pop out here, and our brain is filling in this structure as if it would be coming out as like in a 3D movie or something like that, right? Another thing is the context, which is influencing our perception. So if you see this one, this is an illusion. If I ask people, which are maturated, which are so adults. What do you see? Well, they say, I see two people who are in love or something like this. I think most of you will have seen this too. If I ask children which are younger than 7 years, they say they see dolphins. Okay, how can this be? Because this picture here is structured from dolphins. So, but we always see what we want to see. So what is our context? And I guess that most adults are more interested in sexuality than in dolphins. Maybe if you ask a dolphin therapist, this person might, even if he or she is an adult, say the person sees dolphins, but usually adult people see this more erotic part of the things in these pictures, even if there are these dolphins. So the children in general do not have this thoughts about sexuality, don't know about this stuff, so they see the dolphins. So the context is very important. And so this shows us how social visual perception and therefore art perception is, right? So what we do, we have an objective reality, of course. I'm sitting here on the table, and I can block on this table and you hear this. So there is something objective in my world. But anyway, by perceiving things and doing an actionable perception and doing an active perception, we make an abstraction and our reality becomes subjective. So every person has another kind of reality inside of his head. So to understand this, we need to build a model of reality. And this is what we do in science. We try to build models about how our heads are working. So this is what psychology does all the time, right? We build models of our minds. And therefore, we need to know that our reality is subjective, even if the grounding part, so the real reality, for example, is something objective. Even if you can have really hard discussions with philosophers about this. Is there an objective reality, right? So, but these data here show us that that our brain really constructs things. So this is constructivism, right? Okay, Wolf Singer, who's one of the most important German neuroscientists, said that we never stop interpreting the information of our senses, constructing our reality, right? And he even asked, is there an objective reality apart from or independent from our perception? So we know that we are constructivists, that we are constructing informations from empirical data. So knowing means we have this empirical knowledge, which is, I know, it's not really knowledge, of course. And now there's, for example, Mr. Ramachandran, who's a neuroscience and psychology professor too. He tried to make up a neurological theory of aesthetic experience, just asking, do we have some kind of principles in aesthetic experience too? Well, and he says it's speculation, but everything starts with an idea. So I think so too. So just to give you a grasp what he does, I just want to show you 3 of these examples or principles he does. So one principle is grouping of matches. So what you see here are the Gestalt laws we just seen. So we know that our brain is working from these things and has this one as a basic. So what we are searching for is a kind of a coherence. And often we do this in perception of visual things, maybe of certain artworks too. So, and what do we think is coherent? Well, in most cases, what the laws want from us. So our Gestalt laws. So we think things are coherent when they are suiting, right? Another thing is exaggeration. Exaggeration means is a behavior of the seagull, which was found by Niklas Tinbergen, which is called the peak shift. The peak shift means there's a strong attention to an exaggerated stimulus. What you see here is the picture of a seagull. And the seagull, when she gets children, they are picking at this red thing here, right? And the researcher thought, okay, so they are fixated to this red thing, to this red point, and they are picking on it when they are hungry. So what would happen if I would do 3 red points or red stripes? And he tried it. And what he found was the children of the seagull were even picking more and more and more and more. So by this exaggeration, their attention was even more attracted by these stripes and by being more stripes. So exaggeration seems to be a principle which kind of takes us into something, right? And another thing is that well, our brain loves to solve mysteries, because if we solve mysteries, we push forward our reward system, right? And which is a very important neurobiological system in our brains. And if you look at this picture here, this is a Dalmatiner dog, but it's not that easy to recognize it. So, but our brains can do it. We can see what is in this picture if we take some attention on it. This is, in fact, a really not that easy task for an artificial intelligent pattern recognition system, right? Our brains can do it in a very efficient manner. So these are some principles Ramachandran's thought maybe might have the character of kind of an aesthetic principle. So, and these are just suggestions, but there is research in this direction. I just wanted to show you, right? Okay, but let's look at some connection to arts. So if we are in arts, we have different examples where we need certain laws to do things, where the Gestalt laws are taken into account. For example, here, if you look at this picture here, we think it's a strange situation because this person is so small, kind of from a Lilliput or something. But if you look at the real setting, it's just a physical setting, which is resulting in a quite fascinating photograph. Well, this is a very, very amazing and exciting and well-known experiment from psychology. One of the persons who really played with reality, with subjective realities, for example, is M.T. Escher. So M.T. Escher made these, created these pictures which are kind of impossible. So you can't walk these lines here. But anyway, our brain kind of understands these pictures. So because it wants to make them coherent. The problem on this is that, well, have you ever tried to just copy such a picture, but not with something under it, but from your mind? So just look at a picture from Escher and try to copy it. It's really hard because your brain doesn't want it, because your brain tells you this does not work. Well, but if you look at the picture, it will work because there is this sense of coherence and our brain wants to make something visible to us, which is a good thing. But for example, in areas of law and testimony and so on, it can be very bad, but that's more social psychology. Okay. If you look at this picture, well, here they use Gestalt laws because it looks like this pedestrian crossing is coming out of the ground. Or here you have this Leon Keir picture, which is kind of strange because you have these gummy bears, so to say, on the bridge. Well, so we find kind of principles which are used in art perception too, but that's not the most important thing. The most important thing is here that you all understand that a reality is subjective, and that we have evidence for it, but that we might have a new tool to get into this kind of subjective reality by augmented reality. Augmented reality has the potential and already can put some things into your own reality, which is very special. And we could use this for psychiatry, we can use this for arts or for different things, but we will get more into this a bit later. First, I want to show you one very interesting experiment, which colleagues did from the University of Oldenburg, which is in the northern part of Germany. And what they did, they tested 100 subjects in the following way. They showed them, you had to look at a fixation cross on a computer monitor, and then you have seen 2 circles, and these circles were consisting of these stripes here. This circle here had a problem in the middle, so there were stripes which were not suiting. So there's a mistake, right? But if you look at the pictures, you see them the same way. They look both the same. Why is that so? Because if you look at the picture we have seen before, you have this this R here, which is getting into our eyes and into our retina. We have seen this before. But then the R needs to be transported to our back brain. So it needs to get out of our eyes. And here we have a part where our visual nerves are getting out of our eyes into our brain, right? And there can be no photoreceptors. So you have a part here in the brain, in your eyes, where you can see nothing, right? It's a blind point in our eyes. But what is the brain? We know the fill-in principle. So the brain doesn't want us to see this mistake, and it doesn't want us to know that there is a blind point in our eyes. So it makes a fill-in. So what we really see is subjective reality. So we see two circles which are totally the same. We can't see a difference because we calculated by an eye tracker the distance we need, that you really can't see this thing here because we perfectly find your blind part in your eyes. So that's very interesting. But the more interesting thing, people had to judge which one of these two circles is the best one, is the nicest one. And interestingly, most people, and this is statistically significant result, say that this thing, which is the defective one, is the best one, is the nicest one. So what the experimenters say, that people trust more in the things their own brain constructed. Well, they don't know that there is a difference. They see the same objects, but they decide for the better one, the one which they constructed by themselves. I think this is very nice and very interesting experiment. And what this experiment shows us, that's what I always tell my psychology students, it shows us that that you don't need any expensive stuff to do good experiments, you just need a good idea. And I guess that's the hint for the projects here we are going to run in the next weeks. We need good ideas, and if you have good ideas, we will have great success. I am quite sure. So, but this is very interesting, and this tells us again that reality is subjective, and that we believe more in the things we subjectively constructed in our minds than in those things which are real in our reality, which is really quite interesting fact, I guess. And so the next point would be to talk about how can we use this knowledge, and how can we maybe use augmented reality, virtual reality to get a mix of the objective reality, the subjective reality, and how can we maybe influence the subjective reality of people and maybe use it for therapeutic things or for whatever. But I think there's much potential which can result out of the knowledge we have using these new technologies from AI. But now I give the word to Manu, and we'll come back to you later on. Manu?
Okay, here we go. I'm sorry, I didn't realize that if I didn't want to interrupt, so I stopped my audio, and I didn't realize I need to get it freed again. Yeah, I want to actually build up on what Marc said a moment ago, and that is you just need a good idea, because as you can imagine, the discipline I'm originally from is built up on ideas. It's up for others and maybe later generations to judge if they are good or not, but a whole researcher's life could have happened only thinking about the world, or as we just learned, thinking about how he or she believes the world is reconstructed in the brain. I want to give some short footnotes, as this is the subtitle, about the consequences, what we just learned from Marc as the state of the art of neuropsychological research, what the consequences might be in arts and society so on, and maybe even discuss what the final frontier of bringing all these constructivistic arguments together might look like, and if that might be the age-old question, if we do live in a simulation at all, right? Maybe you can give the next slide. Okay, so here's one first thought. Constructivism, early on, even at a point in time when I believe we were not able to prove it the way Marc just described it, is proven and discussed and debated today in natural science, found its way into philosophy. I brought you a very famous example of how constructivism in societal sciences might look like. This is what Heinz von Förster, an Austrian-based original natural scientist, who then became one of the cybernetics, which of course is the discipline of which, for example, the computer science field, we have much more, much more knowledgeable people than I could ever be on this issue with us. I see one of them nodding here, but of course, cybernetics is the origin of computer science, and it is actually constructivism in action. So what Heinz von Förster tries to argue for in this picture is that on the left side, you see how we believe, and again, this is at a point of time when we did not have the experimental proof that Marc shared with us, how we believe the world works. That is, we have an X, that is our original position. We have an Y, that is our aim, where we want to go. And we have a function that takes us from X to Y. Now, Heinz von Förster says this can apply to everything in society and life. It can mean X is the original position of a company, Y would be a market entry in Saudi Arabia, and F would be how you make that happen. X could be an idea of an artist, Y is how he wants to show it to the world, F is how he gets from the one thing to the other. Now, von Förster tries to make the point that why our brain tries to make sense of the world by getting rid of complexity, so it looks trivial, the reality before we reconstructed it in our brain is what we see on the right side, and what Heinz von Förster famously called a non-trivial machine, because non-triviality, of course, means I don't know if X is where I'm really at, right? Already that, as we learned by Marc, is filtered and reconstructed. I don't even know if Y is an
right.
aim. No, I hear myself. I don't even know if Y is where I should want to go, right? And even less I know, even if we take those 2 points as granted, if my actions will take me from X to Y, right? So that is non-triviality. And the interesting idea, philosophical concept in regards to constructivism to take away here is that this is also one of the first and most fundamental argued times there was a distinction introduced in science between complexity and what in German we would call Kompliziertheit, complicated systems. So a complicated system in this sense of Heinz von Förster, and that is of importance to arts and artificial intelligence research, of course, is defined as a system that has a certain amount of parameters. That might be a huge number. It might be too much parameters to really calculate them and simulate them through in a computer, but theoretically it would be possible. While a complex situation, and that is the world our brain and our societies have to handle, in the philosophy of Heinz von Förster, is defined as an infinitive amount of parameters that interact in such a way that we are not able to determine what's going to happen. No matter how many human brains or quantum computers you would put in line, it is not possible to predict a complex system, but we're living in a complex reality and we somehow have to handle it. So constructivism, that's the old idea of this school in philosophy, always also means reducing complexity. So it makes sense for us, even if it's not anymore how the reality looked like. Now, one consequence of that, maybe the next slide, Mark. One consequence, and I'm trying to push the boundaries, right? There would be many things to discuss, but I brought a certain idea that would be a consequence out of constructivism, and one that is not only interesting for political philosophy, but also for the arts, and especially in Saudi Arabia, where we saw this approach towards artificial intelligent agents. So the question that I want to discuss here, or give to you as the distinguished audience to have in mind over the hackathon, is who is the person? Now, it's a very complex question, but to break it down, at least in Western philosophy, and we see parallels in philosophies of other cultures and regions as well, this originally started very easy by saying a person is someone who's capable of reasoning, right? That is not, and I'm really making this short because we want to discuss and not have a long lecture only. This did not work out for long, because we surely soon understood that it cannot be the brain functions itself, because we would not like to take away personhood, yeah, the moral status of a being, from someone suffering from neurodegenerative diseases. We would not want to say you are suffering from dementia. That means you are not a person, a human being anymore. We don't want to say you're in a coma, you cannot use your brain functions. That means you're not a person. We don't want to say you're a kid, and we don't believe that you're capable of reasoning. That means yet you're not a person. So we needed to find a different way in philosophy to define person, and over many steps it ended up with the idea of being able to suffer, Peter Singer and others, which again has a problem in itself, because we do not know how beings suffer. We cannot be for sure that an animal does suffer, even if it does not have the neurological fundament that we have. It might be the case that only dolphins and octopuses and all these advanced animals suffer, because we know they have the neurological system to suffer, but we cannot be sure that not so developed animal cannot suffer. And I'm jumping again, ending up with something that is in the discussion in political philosophy right now. I call it substratism. There are different names for it. But the basic idea is that if we cannot take capability of reasoning, if we cannot take the ability to suffer, then that's the latest idea in philosophy. Let's go for the ability to have an aim and work towards this aim. This might be the aim to live tomorrow, which is why I food today, but it might be any kind of aim, which means maybe an artificial intelligence agent, someone you play with in your computer games, or someone you came up with as an artist, might be entitled to the status of a person to some kind. Now, this is really connected to a very constructivistic thought, that this would be the next slide. A thought introduced by Oxford philosopher Nick Bostrom many years ago, when he tried to find an answer to the question, are simulation? And this has been become famous as in philosophy of mind as the substrate independence thesis. Now, the basic idea of that is really that we cannot be sure that it's only the brains we have come across so far that are able to have something that that we would describe a mental state. Next slide. That means is that if you follow this constructivistic idea to the end, and that's what I meant when I said I brought you the most extreme example of where constructivism might lead, we cannot be sure that we're not living in a computer simulation. Actually, if you follow Nick Bostrom's argumentation. It is even, but that's maybe only interesting if you're really into that philosophical question. He ends up saying that the probability of us living in a simulation is much higher than our reality being the bottom reality. Why? Because he says there are only 3 scenarios that are possible. Either we never develop the technologies to come up with full immersive simulations, right? The combination of virtual reality, augmented reality, Marc told us about, and an advanced AI that would be able to simulate a world that would not be distinguishable from ours, so to say. So either we do not come with the we do not develop these technologies ever. But if you have a look at what we can do right now, and you say how this will look like in 100 years, in 500 years, in 1,000 years, then it's not science fiction, but it's right. It is. There's a high probability for us being able to develop those technologies. But maybe we kill ourselves before we go into climate crisis, so we will never develop, even if we could have. Second scenario, we decide not to use it for ethical reasons. Well, humanity has never been good in not using technology due to ethical reasons, so that might not be ending up. And here's the final thought of Nick Bostrom. If it's not A or B, then hundreds and thousands and millions of simulations might happen. Every 3rd grade in school will have a simulation to learn about how ancient life was in Rome. And then the probability of us to live in such a simulation would be much higher than to live in the basic reality. Now the question, and that's my final thought I want to share here, is how to react to this. We do not know if artificial intelligence might not be a person, and somehow, of course, there are different approaches. One would be the approach of personal ethics. Should I kill in a computer game? Can an artist, once the SAAI hackathon has ended, simply shut down all the chatbots that she or he has developed? That's a personal decision. That's not my field of expertise and interest. The second perspective, that would be the next slide, please, would be the question of how should we as a society react, which is of course much closer to the questions SAAI is raising here and our institute in Ottersberg is raising. How do these things interact, art and philosophy and society and technology? The final thought, how there might be a political, a societal answer to this could be found in something that political philosopher John Rawls in the 20th century, one of the most important influential philosophers of our time, so to say, called the Whale of Ignorance. Rawls made the following idea happen. We should think about the society we want to live in and the rules that apply in this society based on ignorance towards who we are going to be in that society. So we would not know behind this veil of ignorance, would we be healthy or ill? Would we be male or man or woman? Would we be rich or poor? Would we be educated or not? Would we be an animal or a human? Would we be an AI agent or not? That's how you can now make Rawls' idea broader. And the beauty of this is this was written end of last century as a theoretical concept. Now, building up on what Marc said, the state of debate in natural science and so on that we have today, but also the technology Christoph was talking about that has been developed so far, we could take this concept and we could turn it into a simulation and we could make different states of society visitable to find a new way to debate how we want to structure our society, and that is something I believe that that would be very worthwhile. It is tackling age-old questions of arts. It is tackling age-old questions of the sciences, age-old questions of philosophy. So thinking about simulation as a result of constructivism, as a tool to debate how we want the world to look like, that is basically the main footnote that I wanted to share. It's a huge opportunity at the intersection of arts and technology. And we are already doing that. That's maybe a very final point. This is a very actual paper that is going to be published in Behavior in the near future. And it asks an interesting question that is a question many are discussing right now. Why did we ever come up with imaginary worlds in the first place, right? Why all this fantasy in video games? Why all the fantasy in movies? Why all the fantasy in any kind of arts? And I want to suggest to you to have a look and look out for that paper once it comes, because it's really interesting, and it's cutting edge when it comes to the question, why are we doing this? Because we're doing it more and more. That's the main argument of the authors. We have been building imaginary worlds for centuries and millennia, but now that we have the technology of VR and artificial intelligence, it seems to be the case that we are building more and more imaginary worlds, and empirically more and more of our stories that we are telling as a society to ourselves, that artists are telling. This is very much in line with what Christoph said. More and more of these stories seem to be told in imaginary worlds, which itself is an interesting thing. And maybe the reason is much more easy than what the authors discussed. Maybe the reason is that building up on what Marc introduced us to, imaginary worlds are much closer to our brain and the way it works than the reality, so to say, which is also an imaginary world, listening to what Marc said, but one that we have decided not to call this way. So maybe it's just easier for the brain to spend time in an imaginary world that we call imaginary world. Yeah, thank you. I think you need to get the rights as well.
Yes, now I'm back with sound. So yeah, we're finished with our talk. I think maybe if you watch a David Lynch movie next time, or Twin Peaks, you get a totally new understanding. Because when I watch these movies, which I really love, I know that even all the time I get some new knowledge from some direction. I get some new insights in these movies. It's amazing. So this person is really an amazing artist. So thank you very much for your attention. And if you have any questions, just feel free to ask them. I think I will leave the presentation so we can look into your eyes. So that's better.
Okay, sorry. So, can you hear me?
Yeah.
Yeah. Okay. Yeah, I'm co-moderator. Okay. So, yes. Well, thank you very much. We are inviting anyone to have whatever impression or questions that might follow after this presentation. We have enough time.
We have a question in the chat. I'm just going to read it out. It's from Max, and he asks, are there any other approaches to make AI suffer?
Well, it totally depends on the definition of suffer. So I think the whole continuum of from yes to no would apply here. Maybe there's one thing to be very sure about that talks a lot about our human nature. I don't know if Marc agrees on this, but I guess he will. Human tried. So as long as we came up with AI agents, we tried to hurt them. Sometimes in a for us funny way that would be called video games. Sometimes this was just to see how much the AI can take, and it's totally up to the definition of suffer. I would say yes, it's possible, but maybe that's already the AI controlling my brain here and trying to build up some sympathy for it.
Yeah, I guess it depends on whom you ask. So if you ask a master in psychoanalytics, he will tell you, no, a machine cannot suffer because a machine, until now at least, has no emotions. But you can define it. So what is suffering? Like Manu said, we have to define suffering, and then we can answer this question. So but I guess until now it's not possible that the machine can suffer in the way we suffer. So but from neuroscience, there's very interesting information about suffering, about pain. So we know that we have networks in our heads which are specialized for feeling physical pain, and we know now that social pain mostly is located in the same networks. So a big question is, can we resolve psychological pain with pharmaceuticals against physical pain and such interesting things? So we get to know even more and more about our brain mechanisms. We know that there are people who have two different personalities and really span two different personality networks, which have sometimes the same nodes, but sometimes some nodes they don't share. So people cannot get into the traumatized, for example. So we try to explain these things, these networks in our brains. So
which,
yeah.
interestingly enough, is an ancient idea in philosophy, right? Homunculi, who have two different personalities, right, in one body. Yeah. And it raises interesting questions of human rights. Like if one of them wants to continue living and the other doesn't.
Right, and there we have this interesting connection to social psychology and all the things we do, and that's what I think is so interesting. When I did my habilitation, I wanted to combine social psychology and clinical psychology, because
can machines be social, like, and what defines that? Like, if machines are currently, we cannot define them as social, I would say, beings. What are the properties that may exist one day in some machines we can consider them as social?
Well, I think considering them as social is maybe already possible, because they do social interaction, and for a social interaction, I don't think you really need emotions or something, or affectivity. You can interact socially with a very small amount of emotional stimuli. So, for example, if you look at a high functioning autist, he will not feel that much emotion. But he's functioning very good, and he can do social interaction, not in the way we do, but in a very maybe we could even call it very sophisticated way, because it's very efficient what these people do. So in this respect, I might suggest that there is already some social interaction.
Again, it's a question of definition, I would say, because you cannot be sure that I'm a human being. In the age of deepfakes, I could be a highly developed AI, right? And I could be a simulated myself, and it would be very difficult for you all to know, because we have come very much, we passed the age of the Turing test, and we understood that it's a too simplistic idea. And once again, taking into consideration this continuum, we changed the definition of person over time. It used to be a rich Greek male fella. It was not even the person living in the village next to Sparta that was granted the status of a person in Sparta. And then we made really crazy things, like including women in the concept of being a human being and a person. And so the question is there only a definitive amount of definitions of social, for example? And is it only the idea of human brains, and whose human brains, that can come up with a definition of social? Maybe, as Marc said, someone who is on the autistic spectrum would find many definitions of being social weird, but still would accept them. So I think we passed that line already, and we see it. Just to give a pragmatic example as well, it's also a very more philosophical questions. We are debating that in many areas. let me tell you an anecdote. Christoph told about my work with Mohammed Yunus, the Nobel Peace Prize laureate, right? I was beyond excited when he visited our university spin-off RetroBrain. Marc said a bit about this, where we're working on video games that are used in therapy and prevention in nursing homes. And he was a fan of it, but he was only highly criticizing it, saying all these, robotics in nursing homes, all these ideas of having AI in nursing homes. Is that really something we should aim for? Is it really the right thing to have human interactions done by an AI or a robot, which is an interesting dimension, because if you ask many of the people living in the nursing home, of course, it would be much better if they would have much more humans interacting with them. But many of them are very happy about having a little robot having conversation with them. If you would have asked them before that robot was introduced, they would have said, it's nothing I'm interested in. It's nothing that I would see as a social interaction. Once you introduced it, they seem to be happy to be able to talk to someone. Again, I'm not judging. I agree that nursing should have a much different setting in many parts of the world, but they tend to see it as a social being they talk to, they have fun with, and so on. Yeah. Long story short, answer, it's always about definition. That's not really helpful, right?
I have one more point. If you do social interaction, what you need to efficiently social interact, usually you need some kind of empathy. So if we look at a modern definition of empathy, we have two sides of empathy. One of them is a cognitive empathy, which we call theory of mind too. The other one is affective empathy. So what a machine can do is while cognitive empathy seems to be possible to implement. So you can somehow infer why the other person does something and maybe use it as a model and well, make supervised learning or whatever. But the affective side, that's the hard part. So feeling what the other one feels and understanding that the person does something and why the person does something is no problem, not really. But really getting into the person and suffering because the person suffers. I guess that's the point, which is really, really hard to dissolve. And
which again, many kids have when they play a good, well-made computer game. So I see that with my students, they suffer with the protagonist if it's a well-written story. But that's also where arts came into being. These effects seem to have happened in the world of video games once artists collaborated with game designers, and suddenly you had people very experienced in storytelling. So people from theater, people from literature, and that helped to have this kind of empathy.
So what means that our kind of interdisciplinarity we just do here is I think it's a good way. So
also I shared something, maybe I want to say a comment on that, otherwise I look like a real weirdo sharing only this link. There's a very interesting, so it's always a good idea to look into sci-fi to come up with new concepts and analysis ideas. I know Marc and I share this and many others do as well. There's a fascinating idea in the science fiction universe that is called Warhammer 40K, and that is the machine spirit, Maschinengeist in German. Now, this describes a highly developed a world with highly developed artificial intelligences in which humanity has forgot how to collaborate and work and direct these AI agents because they developed themselves further and many other reasons. But in the end, it's a fascinating idea, I believe, because we see it even nowadays. The concept of machine spirit means that you start to react to highly developed AI in a pretty religious way. They do not know how the AI agents work, so they start to come up with rules like you have to give the AI the following and it will fulfill your wish. And it works quite well as a religion. Now, the fascinating thing about this is this sounds weird in the first place, but just remember yourself, when was the last time you were, and Marc could explain this much better than I can psychologically, I guess, but when was the last time when you were talking to your printer please, I need this. Please work. When was last time you were sitting in an airplane saying, please, machine of the airplane, take me from A to B in a safe way? You know that there's no impact of you talking to your printer, but it seems to be like you do not really know how the printer functions. So you go back into a proto-religious way of working with that being, and you start to say, please finish this printing. So that's an interesting idea, I always believe. And I also think that's a role to play for artists and scientists as well. We need to get rid of the machine spirit as soon as possible. We should not have a generation that do not know how AI works. And the way to get there is by questioning the AI. And that's, I believe, what artists should do. And it's also what we do at our new institute, interdisciplinary.
Okay, I have to, stop here in order to give time for our next speaker. So, Marc and Manu, thank you very much for this insight and philosophical thoughts that you shared with us.